Okay then. So this is chapter 7.4S on transformations 2 for the foundation topics. Okay, so we were looking mainly at transformations in this lesson. I know that you will have looked at other transformations in the last lesson, but this one is just on enlargements. Okay, so when we have an enlargement, we have what we know as a object and an image, much like any other transformation. Okay, so the object is something we start with. So in this question, I would say that was the object, and we're going into our image. Okay, so the image is the thing after the shape after the transformation has taken place. Okay. Also, for an enlargement, we need a thing called a scale factor. So an enlargement is a transformation that makes your shape bigger or smaller. The scale factor tells you how much bigger or smaller it is. Okay. To calculate this, we use our scale factor, which is the length of the image divided by the length of the object. Okay, so the length of the image divided by the length of the object. Okay, so in this one, our image is the bigger one because that is after the transformation's taken place. So we have 1, 2, 3, 4, 5, 6. So that side length is 6 long. So we can say that is 6 divided by, and this side length is 3. So our our object side length is 3. So 6 divided by 3, that is 2. Okay, so we know that this one is 2 times bigger than this one, and we can check with this other side length. So that's 1 high, and that is 2 high. So to get from here to here, we've multiplied by 2. To get from here to here, we've multiplied by 2. Okay. In this one, it's a little bit different. Still an enlargement. What's different about this one is that it's getting smaller. So this is our object this time, and this is our image. Okay, so our enlargement is making our shape smaller. So this is a side length of 2. This is a side length of 1. So the length of our image is 1, and the length of our object is 2. Okay, we can check that with the other side. So the length of our image is 2 and the length of our object is 4. So 2 divided by 4 is 1/2 as well. Okay, so this shape here, this triangle, is half as big as this one here. Also for a enlargement, we need something called a center of enlargement. So this tells you where you're enlarging from. Okay, so that'll tell you where your image will end up. Okay, we'll talk through that in a second. Okay then, so moving on to example 1 from your textbook, you can see that we need to enlarge this shape by a scale factor of 2 and at the point of enlargement of P. Okay, so you're given P in this example, and that's the shape we're enlarging there. Okay, so what the book does is it uses a thing called projection lines. Okay, so you start at your center of enlargement and you connect it to one of the corners. Okay, one of the corners of your shape. Don't take the ruler off and extend and project that further. Okay, do the same thing for all of the corners of your shape, all the corners of your object. These two are in the same. So I'll just extend that out there. Okay. So as you can see, there is a line going through every single corner of our shape from our center of enlargement. Okay. Now we have a scale factor of 2. Okay. I can see that this corner here is 1, 2 away from our center of enlargement. Okay, so 2 times further than that would be 4. So 1, 2, 3, and 4. Okay, so that corner is going to end up there. This one here is 1, a little bit, 2, so about 2. So that's going to end up about here. Okay, so 1, 2, and then we're going to do another 2 because it's double 1, 2. So 2 times. That's going to go there. This corner, so this corner here, goes 1. So now it's going to go 2 when we enlarge it. So 1, 2. We're going to enlarge this next one. So this one here, 1, 2. That's going to be enlarged by 2. So we're going to move it 2 times further away. So 1, 2, 3, 4. And join them up. And we can see that that has worked. I would always check that your side lengths are twice as long in your image as they are in the object. So this is 1 long, this is 2, this is 2 high, and this is 4 high. Perfect. So that's 2 times bigger. Okay. An alternative method doesn't include drawing these projection lines. It can get quite messy. You can just count the squares. Okay. So in this one, we would have a look at P, our our centre of enlargement, and we're going to just count how many squares it takes to get to each corner. Okay, so I'm going to start with this one again. So 1 along, so 1 to the right and 2 up. Okay, so now what I'm going to do is I'm going to times both of those by 2. So we're going to go 2 along, and then we went 2 up before, so now we go 4 up. 1, 2, 3, 4. Okay, so that's that corner is this one here. Now we're going to look at this corner. So 1, 2 to the right and 1, 2 up. So now we're going to go 4 along. 1, 2, 3, 4 and 4 up. 1, 2, 3, 4. Okay. We then have a look at this corner. We're going to go 1 to the right. So we actually got 2 to the right when we're doing our enlargement. So it goes to there. And for this one here, this corner here, we go 1, 2 for our image. So we're going to go 2 times further than that for our object, we go 2. And then for our image, we're going to go 4. So it's 2 times bigger. 1, 2, 3, 4. Okay. And like we saw before, this shape is exactly the same. Okay. So they are 2 alternative methods for doing enlargements, and I'll use both of those through this lesson. Okay, so this question, so this example you won't find in your textbook, but it'll come in handy when it comes to doing your exercise later on. Okay, so you'll see that, so this question reads, enlargement scale factor of 3 and 1, 2 centre of enlargement. Okay, so you will see that you're given a coordinate. That is because this question is different, slightly different from the previous example. This one we're on a coordinate axis. Okay, so we can use this coordinate here, along with our scale factor to answer this question. Okay, so we will find where this is on our coordinate axis. So we know that coordinates are always given x, y. So our x direction, we've moved 1, so we go along to 1, and in the y direction, we move up 2. Okay, so we go up to 2. Put a cross on, mark it P, because that's our point of enlargement, and let's get going with the actual enlargement. So our scale factor is going to be 3, so we're going to draw our projection lines in again. I will do it with the counting squares method in a sec. So draw a line from the centre of enlargement and project it out through each corner. So start off by joining up centre of enlargement to corner and then just project it out. Centre of enlargement to corner, centre of enlargement to corner, and then project it out. Okay, so you can see from here, so you can go 1, 2, we've gone up, we've gone away from our centre of enlargement 2 squares, so we can now move away from our centre of enlargement 3 times 2, which is 6. Okay, so 1, 2, 3, 4, 5, and 6, which is there. We then look at this corner, so we've moved 1, 2, so we do 2 times 3, which is 6 again. 1, 2, 3, 4, 5, and 6, which is there. This bottom corner here, we've moved 1 away from the centre of enlargement. So start the centre of enlargement, 1, 2, 3, 4, we've moved 1, so it's a scale factor of 3. So it's 1, 2, 3. This corner, we've moved away from the centre of enlargement 2, so we're going to start back at the centre of enlargement and move away 1, 2, 3, 4, 5, 6. 2 times 3 is 6. Okay, join them up. And that is your shape there. Okay, I'd always check that our side lengths are the same. Our side lengths are the scale factor bigger, so we have 2 going up for our object, and our image 1, 2, 3, 4, 5, 6, and 2 is 3. 2 times 3 gives you 6, so that's perfect. And check on the bottom as well, just to make sure. So in our object, we've got along in 1. We times it by 3, we get to 3, so that's perfect as well. Okay. Okay, so for an alternative method, we have counting the squares. So in exactly the same way, we're going to start with the same centre of enlargement. So that's always your first step. Mark on where that is. So we go along 1 and up 2, as we did earlier. Okay. We can then start at our centre of enlargement, and we'll be looking at this corner here. Okay. So we count how many squares we've moved in the x direction and how many squares we've moved in the y direction to any given corner of our shape. Okay. So in the x direction, that'll be how many squares have we moved left and right, and then in the y direction, it'll be how many squares have we moved up or down. Okay, so for this one, we have moved up 1 in the x direction and up 2 in the y direction. Okay, so when we enlarge this by a scale factor of 3, we move 3 in the x direction, because 1 times 3 is 3. And then we've moved up 2 in the y direction, so we're going to move up 6, because 2 times 3 is 6. 1, 2, 3, 4, 5, 6. So we're going to end up there. Okay, this corner now, we're going to start at our centre of enlargement and 1, 2 in the x direction and up 1 in the y direction. So we move 1, 2, 3, 4, 5, 6 in the x direction, because 2 times 3 is 6. 1, 2, 3 in the y direction. Okay, so we're going up 1 here. So we got up 3 when we do our enlargement. This corner here, we've moved 1 in the x direction. We haven't gone anywhere in the y. So 1, 2, 3 in the x direction. And for this corner here, it's 1, 2 from the centre of enlargement. So from the centre of enlargement, we'll go 1, 2, 3, 4, 5, 6. Join them up. Once we've done all 4 corners. And you can see this one gives you a much neater result than this one, but either method is fine. So I would still check, are the side lengths 2 times bigger on this one? 3 times bigger on this one. So we've got 2 squares here, and we've got 6 squares there. So yeah, that's 2 times bigger than this, 3 times bigger than this one. 3 squares there, 1 square there. So that's 3 times bigger than that one. So you won't find this example 3 in the textbook either. It'll just help for you finishing off the harder questions on your on the exercise later on. So you'll see that in this example, much like example 2, we've got our coordinate axis, okay? And our centre of enlargement here is given as a pair of coordinates, okay? Again, we have x and y, and we know that we go along 10 in the x direction and up 2 in the y. So if we mark on our centre of enlargement, that's a good step. This question says, enlarge a by a scale factor of a half. So that is the difference in this question to the one that we've just done. Okay, although it's a half, this is still an enlargement, it's still exactly the same thing, but we can expect this shape to be getting smaller after this enlargement, okay? So we need to draw in our projection lines. So from your centre of enlargement to each corner, draw in your projection lines, and count how far away each of them is from your centre of enlargement. So how far each corner is from the centre of enlargement. So this one, we go 1, 2, 3, 4. So we know we've gone 4. We need to go half that distance from our centre of enlargement. So starting back there, we're just going to go 1 and 2. Okay. For this one, it's a little bit trickier, but I can see that the first time we cross, another square is here, and the next time we cross, another square is there. Okay, so there are 2 lots of this distance. This is the halfway point. The scale factor of a half means that it's going to cross there. Okay, this is where that corner is going to end up when it is transformed. This one here, same problem again as this one. We see that the first time we cross over is here, the first time we cross a definite coordinate is there, and the second time is there. So halfway has to be here. Join up those points. And that is your enlarged triangle with a scale factor of a half from the centre of enlargement 10, 2. It's the same question again with an alternative method. We know that the centre of enlargement is at 10, 2, so that's our x and our y again. That is 10, 2 here, so along 10 and x and up 2 and y. And then we've got a scale factor of a half again. Okay, so counting the squares method, I'm going to start with this corner here because it's the closest. So we go 1, 2, 3, 4, up, and 1, 2, 3, 4 across. Okay, so half of that, half in each direction, is 2 up and 2 across. Nice and easy. Okay, this corner here, we go down 1, 2, 3, 4, 5, 6, 7, 8 to get directly underneath that in the x direction, and 1, 2, 3, 4 in the y. So we're going down 8 in the x direction and up 4 in the y. So we're going to go down 4, so that's half of 8, 1, 2, 3, 4 in the x direction, and up 2 in the y direction. 1, 2, because 2 is half of 4. This top corner here, we're going to start at our centre of enlargement, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to get in line with that corner. So we've got 10 up in the y direction, 1, 2, 3, 4, 5, 6, 7, 8, and we've gone down 4 in the x. Okay, so we've gone up 10, so now we're going to go up 5 because that's half of 10. 1, 2, 3, 4, 5, and we're going to go across 4. So we're going to go down in the x direction by 4 because that's half of 8. 1, 2, 3, 4. Okay, they're the corners of our enlarged triangle. So we can join those up, and there we go. Okay, just to check these, we have a look at these 2 sides. So the sides of our image, sides of our object. So object has 1, 2, 3, 4 in this direction. This one has 2. Okay, so 2 is half of 4. So we have enlarged by the correct scale factor. Again, we'll check this. So our object has 1, 2, 3, 4, 5, 6. A length of 6 in the height, and this has 1, 2, 3, a length of 3 in our height for this one. So that is also being enlarged by a scale factor of a half. Okay, so 3 is half of 6 and 2 is half of 4. So we've checked that that works.